So with that, we'll go ahead and start. This is the wastewater operations operator certification training event for the wastewater collection systems. Before anything, let me just introduce myself. My name is Daniel Cardenas. I'm a senior operations technician for Corolla Engineers. Quick little background. And I'm going to click away from the picture just because I don't like to see myself. I've been in the industry for about 18 years. CWA wastewater collections operator 4. Also have some experience in the water side of a water distribution operator level 4 in California, and a water distribution operator level 3. I'm sorry, in California, and wastewater treatment operator level 4 in California. And currently, I'm doing work out here in Texas, just doing some consulting for a 320 MGD treatment facility. But my whole career started in the collection systems operations. I did that for the first 8-9 years of my career, and it's always been something that I kind of go back to. So enjoy doing this right now. And before we start, I'll show this current slide again at the end of the presentation. This is a link to provide feedback for the training. You can tell folks that are listening, you guys can go ahead and tell whether you liked it, didn't like it, what we can do better. That I think that'll be beneficial. Feedback is always good and bad feedback altogether. So all accepted, it's all that make things better for everyone. We'll start off with the first section, and the first section is really the introduction to wastewater collection systems, and we'll talk about the purpose, the components, and the objectives. So to start off, we'll do a quick history lesson, right? I want to ask everybody the question, why? Why do we do what we do, right? Because the role that a collection system operator takes is a very important one. So I wanted to just, why do you do it, right? Couple of things, right? If we didn't do our jobs, things would get a little messy, right? So we do what we do to keep our living quarters clean. And we do what we do to keep people from getting sick, right? These little guys right here, little picture that came up on screen, that's those are guys that we want to avoid. We can't see them, but they definitely affect our lives, right? These are things like bacteria, viruses, protozoa, helmets, which are intestinal worms, right? You got a couple of different examples there. These are all things that we want to avoid. So let's do quick little history. So before collections, modern day collection systems existed, this is kind of what things look like. This is what they called a chamber pot, and these things can come in different shapes, sizes, designs. And believe it or not, this is something that's still kind of used in modern day applications. You can see that, folks would kind of do their business in these things, and then nowadays we just kind of take that, flush that into the collection system. But what they do back in the day, right? Where did this stuff all go? Well, historically, it just kind of went out into the road, right? I thought this was a good illustration. It was just kind of tossed out there on the roads or on the side of a house, on the street. That's kind of what they did. Things kind of progress, and depending on what region of the world you were in, you may have an outhouse out in the field. Believe it or not, this is a major upgrade, right? So kind of a cool, neat way. And if you were really fortunate in medieval times, you kind of just did your business in almost like a modern day restroom, and somebody would have to, it would just collect at the bottom of a castle or tower, and you had your classic collection system operator there that would have to take care of the business, right? So let's get into the definition of a wastewater collection system. Wastewater collection system collect the used water from homes and businesses and convey it to a wastewater treatment plant. There's major components. The major components of the wastewater system are kind of shown in this picture, but we're going to go individually to each one and talk about them a little bit more. So we're going to start from the beginning of the wastewater, most public agencies, wastewater systems, and then kind of go on, right? So everything kind of starts off at the lateral. Now, a lateral is a part of a building's plumbing system that connects to the building's waste plumbing, to the public sewer main, usually located in the street. Laterals are typically privately owned. This changes, of course, based on your agency and agency responsibilities. Worked with a lot of agencies, or worked around a lot of agencies that also take care of laterals because they own the trees that may cause the issues with the laterals. Laterals carry human and industrial waste, right? So laterals have multiple purposes, and like we talked about, laterals can have issues with roots, grease, separated joints, cracks, and breaks. Here's your typical lateral demonstration. It's a private sewer lateral will go into the public sewer main. One of the things that we didn't talk about was a cleanout. A cleanout is a subcomponent of a sewer lateral or sewer main, allowing access for cleaning and inspection. Some of us operators have definitely encountered situations where cleanouts are not existent in a private lateral. It's one of those things that you want to make sure you have. So let's talk about a sewer main. A sewer main carries wastewater from the sewer laterals to the trunk sewer lines or wastewater treatment plants. Sewer mains are made up of different types of materials. And we'll talk about the different types of piping here: VCP, PVC, ABS, ductile iron pipe, CIP, cast iron, asbestos, reinforced concrete, right? There's different types of sewer mains that we'll encounter out in our agencies. Just wanted to give you guys a little snapshot of different types of things that you'll see out in the two most common that I've seen are definitely the VCP, which a lot of folks are getting away from, and the PVC, right? So now the trunk sewers, right? This is kind of the thing that most people think about, right? Your Ninja Turtle sewers, except most trunk sewers aren't really like that, right? Trunk sewer is really a main artery of a sewer system. It's a sewer line that receives wastewater from multiple branches and sewer lines. Trunk sewers are larger lines leading to the system's lift stations or water treatment plants. I wanted to show this one. I mean, it's cool when you see these big, huge trunk sewers in major cities, and I think that's what people think when they think of the Ninja Turtles. But it's like I said, most sewers and collection systems aren't like that, and really the Ninja Turtles, those of us in the industry are more in storm drain lines, not really sewer lines. But now sewer interceptors. Sewer interceptor is a major sewer line that receives flows from a trunk sewer line and directs it to a treatment facility. The picture you see here is an interceptor in New Jersey that was being built in 1920. At least the description of the picture that I saw was that this interceptor was 22 miles long. So it took quite a bit of trunk sewer lines in that interceptor directing it to a major wastewater treatment facility. Here we have a picture of a manhole, and cool little breakdown of what manholes look like. A manhole is an opening to a confined space. I really want to kind of hammer down the confined space part in a bit, and we'll talk about that more tomorrow. Manholes are typically installed as part of the sewer main trunk line interceptors where flow is being redirected. Manholes are access point for maintenance, debris removal, and other maintenance activities. Installation of manholes is typically 300 to 500 feet apart to allow for cleaning equipment to reach. And I wanted to throw out there again, active sewers, manholes are confined space, and active sewers commonly have changing atmospheres. Those of you guys that have to do some work in manholes, and a lot of us operators do, I just wanted to make sure that you're aware. It's too often that you see, especially in the construction side, but those of us in the maintenance side, folks get a little too comfortable around these. Did want to also kind of talk about the steps a little bit. It's very common and I think a lot of new manhole structures are kind of getting away from these steps because these things tend to corrode or get a little weak. I would never rely on any of these steps. treat every manhole like a confined space. There's definitely hydrogen sulfide corrosion, or definitely different types of corrosion on these steps, and they're not the most reliable. So there's just an awareness, safety. So once again, a manhole is a confined space. Now there is different types of manholes. I wanted to kind of highlight a drop manhole. Drop manhole is used when the difference in elevation from the incoming and outgoing sewer line cannot be accommodated. Sewer systems should attempt to adjust the slope of their sewer system to avoid the installation of drop manholes. Now, drop manhole is kind of unique, right? Because in order to clean the incoming line to that manhole, you got some really skilled operators, and I'd love to hear, what type of things you do. You got some guys that are really great at flipping a hose or whatever cleaning equipment into that top of that drop. Some guys get really creative with, shovels and spoons and ropes, and everybody has a different technique of how to clean out a drop manhole. And anybody in the collection systems operations that's had to clean a system with multiple drop manholes knows that it's definitely a challenge. Let's talk a little bit about lift stations. Lift stations use pumps to lift water from lower elevation to a higher elevation when gravity sewers are not feasible. Used to work with a lot of great old operators, right? The classic saying is, crap goes downhill, right? Eventually you get so far low that you need a lift station to pump it back up to an elevation or a wastewater treatment facility. Lift station effluent lines, also known as force mains, vary. Typically, they're short lines going back into the gravity sewer. Occasionally, they can stretch miles long. The agency I worked at in Southern California, we had a force main that went like 7 miles long, I believe, to the wastewater treatment facility that I used to go to through a golf course, which was kind of fun to inspect. So I took this picture from Xylem just because I thought it was a very great descriptive picture that kind of showed us different components of a lift station, for those of you that are not aware of a lift station. Now, your typical lift station influent line, which is this represented by this orange pipe, would normally be a little bit higher than that. So that's the only problem with this illustration that I have. But these are all basic components to have at a lift station. Of course, your pumps, and you want to have redundant pumps there for any potential failures. Your floats, which indicate your low, highs, and off levels, or high levels, high level, low level. Your force main, which is the effluent line, which is a pressurized line coming out right from the pumps. Check valves, keep flow running in one direction. Isolation valves. And of course, your typical lift station is going to have a control panel that run these pumps. Now, I do want to ask a question, and I'll see if anybody kind of responds in the chat. I don't see any chat action right now, so maybe I can get some help there. Does anybody know what's a quick way to find out whether your check valve is not holding? I'll kind of give an answer, right? Well, one, if you see this wet well level kind of filling up a lot faster than it normally will, operators should know, hey, there's probably an issue with the check valve, right? So you can lock out, tag out your pumps, you can close your isolation valves, you can clean out your check valves and see if you can clean that out or replace it. Those are important things. Obviously, if your check valve isn't holding, then this whole system won't be very efficient. The pumps will have to run a lot more often to maintain the flow. All right. Other kind of uncommon, semi-common things to see are a siphon, right? Siphon, also known as an inverted siphon, are sewer lines installed lower than normal gradients to pass under obstructions such as water courses and roadways. Siphons usually require additional maintenance, right? These low elevations leave a lot of solids at the bottom of the siphon. Siphons sometimes are constructed with 2 barrels for maintenance purposes. We had a pretty long siphon, or we had multiple siphons in our agency, kind of like this, that went under waterways that just needed a little extra TLC. We were fortunate enough to have the double-barreled ones, so if we isolated or had to clean out one section, the other section kind of maintained the flow for a while. Usually, yes, a lot of heavy debris that was pulled out of a siphon. Now, diversion structures, right? Usually a structure that can divert wastewater from one sewer to another. Problem with this picture here is both of these gates are closed, right? So not really the way you want to run your diversion structure. Diversion structures are effective at assisting regulating flow into a sewer system. So if one side of your system is kind of getting too much flow, you could always send it to another direction. Typical design involves a slightly elevated weir that allows the flow to be diverted into another direction. And I have a short video here. The sound may not work from some of our trials here, so if it does, Tina or Jason, if you guys can let me know.
Yeah, I'm not hearing it. Just let you know.
Okay, thank you. I appreciate it. So I'll do just kind of highlight the main points that I wanted to highlight in this video here. You know, typically we want the velocity greater than 2 feet per second. Then we kind of get into a nice little overview of what a collection system looks like. I'm going to skip through some of this since you guys aren't missing much. Trust me, it is not the most. It's a very informative video, and if we give out the presentation link, I encourage you guys to look at it. American Water College is a great resource, but it's not always the most entertaining, right? So I did want to talk about the different methods of moving wastewater. Most common, of course, is gravity, but there is a low pressure and vacuum wastewater or wastewater collection systems that I wanted to highlight. And let me close that here. Here's your typical gravity system, which we'll be talking a lot about today. But I really just kind of wanted to show you these low pressure systems and the vacuum systems, which all kind of create just kind of give you a low pressure to kind of let you get through different grades. Typically, your low pressure and your vacuum systems are going to be in less populated communities. Very uncommon in the industry, but I just wanted to make sure that you guys had an awareness of these different items, and they exist. We'll move on from there. I also wanted to talk about combined collection systems. A lot of major cities will still have these combined major systems. It's a collection system designed to carry both sanitary wastewater and stormwater surface runoff. These combined systems are, I said, a lot of major cities still have them, and a lot of them are trying to get away from them, because typically what happens here is you get heavy rain and your wastewater and stormwater goes into the same system. The idea was you had a weir or a dam that would kind of grab all the wastewater and send that to the wastewater treatment plant. And your surplus water during heavy rains would go overflow into your rivers and different waterways. Problem is, typically you'll get some heavy rain that overflows. These systems have kind of been outgrown, outdated. They're still out there. A lot of major cities have them. I'm not sure how many in Arizona may have them, may or may not have them, but hopefully you guys don't. But it's an awareness that they exist. And another quick little term that you guys need to know is an easement, right? An easement is a right to cross or otherwise use someone else's land for a specific purpose. I wanted to throw that out there because typically we work with there's a lot of easements in certain systems. You see a sewer line running through an easement area here. Now, I always used to like to tell my operators back home that, hey, easement is kind of one of those things where you kind of have to co-op with the customer. A lot of what we do is really customer relationships and customer support, and customers don't necessarily like when you're in this area, even though you have the legal right to be in this area. they're not always happy, right? So that's the value and the importance of a good operations team, right? Because when you have a good operations team and you've been there for a while, you understand customers and their characters and what they like and don't like, and develop a relationship with these customers so you can go and do your work, and you know, they'll grant you access, and it's always important to be able to just work with these folks. Technically, you have the legal right to be there, but it's usually just the one individual area that your easement is through. So this is a great example of an easement that just kind of comes through an area. There's no access without being able to talk to that customer. So wastewater system collections objectives. I'm sorry. Wastewater collection systems use water from homes and businesses and convey it to a wastewater treatment plant, right? So what is the objective of a wastewater collection system operator? Let's talk about that for a bit. So effective operations and maintenance programs include preventative operations and maintenance, or O&M programs, right? These are incredibly beneficial to help minimize their environmental and public health impacts. They help reduce sanitary sewer overflows and backups. They help reduce odor, liabilities. They optimize a good operation and maintenance program is going to optimize the cost and resources that are being used. It's going to increase the life of the components. It's going to build community trust and support, right? And get a picture of some of the things that you guys are doing day by day. This is a root treatment that's being applied, and this is cleaning out a wet well. We'll talk about these things a little bit more in a bit. So what happens if you're not running an effective operations and maintenance program? Well, these type of things kind of get costly. Increased sanitary system overflows create, environmental impacts, right? These things like pipe failures and tree roots, tree roots, sewer line blockages, cracked and offset pipe settling. All these things kind of contribute to a bad operations and maintenance program. Another thing to look out for is manhole deterioration, cracked or broken barrels, grouting issues, restricting flows, and traffic accidents. All these things can contribute to sanitary system overflows, legal issues, financial penalties, negative public perception and trust, and you definitely don't want to be the folks that put these folks in this, the team that put these folks in this predicament, right? You see sewer kind of backing up to somebody's home. All right, so talk a little bit about sewer system cleaning objectives. This is a lot of what folks do out there, right? Sewer cleaning is sewer system cleaning or pipeline cleaning is very important. So system cleaning is an integral part of your O&M plan. The objective is to proactively prevent overflows and blockages. Good system cleaning extends the useful life of your gravity sewer system. It lowers the cost of rehab and replacement programs, and it helps you avoid any penalties with overflows and wastewater and waterways. All right, let me see if we can get some involvement here. Quick question. So what are great maintenance programs based on? If you guys can type a question in the chat, that would be really helpful. And so you answer either A, a history of emergencies, B, seasonal requirements, C, preventative and corrective principles, or D, documentation. And I can't currently see anything, so I'm going to keep moving with it, and you'll start seeing some of the incorrect answers start disappearing from the screen here. And the correct answer there would have been preventative and corrective principles, C. The things that you guys do make a huge difference in and how our collection systems work. Now, what is the goal of preventative maintenance? A, to satisfy regulations. B, to avoid breakdowns, damage, and harmful depreciation. C, to use up your budget. Or D, to build community relationships. Give everybody a second here. And the correct answer would be to avoid breakdowns, damage, and harmful depreciation. Now we're moving on to section 2 of this training. We'll go ahead and start this section off a little bit and then kind of take our break in about 10 minutes and go from there. This section is really on the inspections and testing, the kind of more of the things that you guys do out there. Proper inspection and testing helps identify issues and issues or potential issues in the collection system. Various issues can be identified before they become major problems. Inspections help identify hotspots, subsidences, improper installations, design deficiencies, improper tap-ins, surcharging, other environmental problems caused by roots, other maintenance deficiencies, and inadequate sewer use, right? This all comes from the lack of enforcement or improper tap-ins, of course, which we talked about. Some of these things are the things that you guys discover during inspections, right? You see top left corner here, you see a bunch of fog, grease filled up in a pipe, right? Those are things that you want to be aware of that are, potentials for blockages and backups. You have some roots in the top right corner of that picture there, a broken pipe on the bottom left corner, and you see, or cracked pipe on the bottom left corner and broken pipe in the bottom right corner. Another important part of like your inspections, right? And we'll talk a little bit more about cleaning and CCTV inspections in a bit, right? But these things in coordination make a difference. And here you see, this is obviously a CCTV inspection, kind of seeing how effective your cleaning is. And it really helps. One of the things that I'd like to point out here, this nozzle and this cleaning, although looks like it's doing a pretty decent job of cleaning outside of the void on the side of the pipe there. I mean, it wouldn't, on a larger pipe, this having this nozzle in the bottom of the pipe isn't typically the best practice for cleaning a sewer line. Of course, you want to try to get that nozzle, maybe not quite at the center, but a little bit more centered to kind of clean out that whole diameter of the pipe. Apologize. Next thing I want to talk about, one of the goals of your inspection and testing is to discover inflow and infiltration. Right? These are major problems to our sewer collection system, inflow and infiltration, also known as I&I. I&I causes hydraulic overload, which begins causing surcharging and SSO issues, or sanitary system overflows. This is a major problem because it increases operational costs at lift stations and wastewater treatment plants. The more flow that you have coming in because of infiltration and inflow, I know the more issues you have at your lift stations and water treatment plants, it's costing more to run those pumps. You start backing up. It's costing more chemical to treat all your flow. So on one hand, we try to get rid of these combined systems, but if we still have some inflow and infiltration within your sewer system, you continue to have these issues with surcharging and extra treatment costs. Inflow, a little bit more in depth, is a water that is not polluted that should be in a storage draining system, not a wastewater collection system. I kind of threw this picture of this manhole here because a lot of times we always see the often overlooked culprit of inflow is a lowered or a manhole that's kind of below the grade, kind of lets water just build up there and just add extra water into your sewer system. And infiltration happens when water enters a wastewater collection system through deteriorated or broken pipe joints. It's a cool little GIF I found on infiltration and what that looks like. Another term that you guys want to be familiar with is exfiltration. Exfiltration is the leakage of wastewater out of sanitary sewer through broken or damaged pipes and manholes. You see that here. Here's the concern with exfiltration. You deal with you end up having untreated sewage in waterways. You end up having groundwater contamination, and it kind of depletes the purpose of what we're doing here, right? We have the potential public health issues because of the exfiltration. Exfiltration contains multiple pollutants. The causes of exfiltration, of course, are cracks, broken pipes, other utility work that's happening, right? That cause these broken pipes, street repairs, failing joints, ground shifting. If you're in Southern California, like I worked, ground shifting was a very common thing. And another picture of kind of what exfiltration looks like, right? If your sewage is getting to your storm drain, this is getting your creeks and your freshwater supplies. It could actually just go down to your groundwater supply and kind of create some issues on the freshwater treatment side too, our freshwater supply. So let's talk about different locations where inflow and infiltration usually happens, right? So, and different solutions to these problems. Now, manholes, like I mentioned, are very common for inflow and infiltration, right? You could always fix that by raising the elevation of a manhole, sealing or repairing the manhole barrel, installing watertight covers, and sealing the covers to install sealing the covers or installing inflow protections. Now, I did say a warning on this inflow protection. There's these covers that are very common in the industry, very cheap, very easy to install. Have a kind of, just based on operator experience, I have a little bit of a problem with them because what happens? Typically, water kind of build up inside this cover, and you'll get a lot of debris or mud, or what happens is the next time that you come in to do maintenance, or if you don't do maintenance, usually you have so much weight and these things kind of get old and brittle over time that they'll break. And I've been in a couple of situations where these things kind of just collapse and fall into a sewer line, creating an issue for the system altogether. Also, they're not very easy for operators to pull these things out. And they have some with cool designs, but usually because these things are plastic, for efficiency purposes, I've seen operators kind of take a manhole tool to the side of these things and just kind of poke a hole in to drag them out a little bit, especially when, like I said, when they're weighed down and heavy. Usually these are going to be installed in areas that you already know are getting inflow and infiltration, which means they'll be full of water or full of debris. So that's my little warning with those covers. And then we talked about sealing the covers. Usually you'll use a little tar seal like that'll go around the manhole ring and cover that kind of gives a tighter seal to your manhole structure. You can do similar things with clean outs and pipes, right? These are all different method or locations of inflow and infiltration and different suggested solutions. So here are some operator tips on identifying potential failures. Of course, one great way of operating potential failure is by looking at your lift station trends or flow rates after storms. Now, if you look at your trends and flow rates, and I'm not sure why I keep losing my. If you look at your trends and flow rates, and you start seeing a higher frequency of peaks and valleys, or it's usually an indicator that something is going on. Typically, you can develop a trend that looks the same. Most wet wells and they'll kind of get the same amount of flow, similar times, unless there's a special event happening. Now, if you notice higher peaks during rainy events, then it's a good indicator that you're dealing with a lot of I&I issues, right? You can help identify these issues also by inspecting your manholes, and it is suggested that we inspect manholes every 1 to 5 years. Different methods of inspecting manholes include visual inspections, CCTV inspections, and of course, the frequency of these inspections should increase in areas with heavy traffic. You could also inspect your sewer lines, once again with CCTV equipment, dye testing, smoke testing, air and water testing, all things that we'll talk about a little bit today and tomorrow if some of you guys are joining tomorrow. And documentation is important. So if you notice that there's an area that you have to clean, or a lot of your documentation should include heavy debris or different things that you find in the system, that's going to give you a good indication that, hey, there's been something else there. Maybe we should look for I&I issues. So reviewing the documentation is always important. Now, once again, we won't be able to hear this sound, but I did want to show the manhole inspection equipment. There's some really cool CCTV equipment out there that'll help you guys along the way. And I'll talk through it a little bit. Now, I am not trying to advertise any particular brand or any particular piece of equipment. There's a lot of competing equipment out there. I did just find some cool videos that I wanted to share that'll give you guys an indication of, how some of these jobs are taken care of. In this case scenario, they have a manhole inspection CCTV. I mean, this CCTV camera is really designed for manhole inspections, and you just kind of drop it down and you'll see it kind of just drops down to the manhole, and it takes a bunch of pictures of just the barrel of the manhole, the bottom of that line, and it'll give you good documentation of what it looks like, whether there's any deficiencies down there. Some of these things are really high tech, and how much detail they give you and where they see the openings, right? That one kind of showed where the sewer line was. All this stuff kind of gives you a great overview, right? Help you make assessments of where to apply your efforts when it comes to either manhole rehab or cleaning, things like that. All right. So let's talk about the frequency of your inspections. Well, inspections should always happen upon installation and acceptance, right? You want to make sure that the manholes that you're accepting as an agency are already in good condition. You'll be surprised how many new installations are just not adequately sealed. It's a very common thing. We talked about inspecting every manhole every 1 to 5 years. What are you inspecting? Your lid elevation, your structural integrity. You're inspecting manholes for vermin and infestation. These guys can get in there pretty quickly, right? Some of those that have been in the industry run into these guys a lot of rats or mice and roaches and different infestations happen within manholes. I've seen beehives beehives inside manholes that can be a problem. So be careful, of course, when you guys are inspecting manholes. It still matters. PPE and safety still matters. So equipment to think about when you're doing manhole inspections, of course, traffic control, your PPE, gas detector, blower, and tripod in case you have to make an entry. All right, those are important for equipment in recovery or a physical inspection, right? Some folks like to get in there and put their eyes on things. Not everybody is not everybody is as fortunate to have all that cool CCTV equipment. Really, the agency that you're in and budgets really make a difference on what equipment you have. So I know we're all trying to get there, but some folks are still doing inspections the old school way of getting in there, right? So make sure you have your gas detector, blowers, tripods. And I kind of like this setup in this picture here where this guy's still using his harness, and he's still tied off. Yes, he's using the runs there, but he's not relying on those runs for raising him and lowering him, he still has good fall protection and a method of recovery. It's also important to kind of have methods of measurements, right? You may want to measure your flow depths, verify your pipe size, verify the invert. Of course, if you don't know what an invert is, the invert is defined as the elevation of the inside of the bottom of a pipe, trench, culvert, or tunnel. All things that you guys want to keep in mind. And then we're getting on to sewer line CCTV inspections now. I know it's been kind of 40 minutes since we started. I don't know, Tina, is this a good time for a break?
Sure, if that works for you. We also had a question from David. Would this also be recommended for lift station inspection?
So I've seen them used for lift stations. Usually, though, the lift stations are kind of a little, and I can't see any chat, so I appreciate if you can always interrupt me with a question because I don't see anybody's chat. They can be used for lift station inspections depending on the size of the lift station, though. They're kind of more of a, depending on the piece of equipment that you have. Like I said, there's a lot of different vendors with different prototypes. And depending on the type of lift station, you'll be able to see some of it, not all of it. Of course, lift station inspections can get a little tricky based on size. So I don't know if that answers the question. Is that the only question currently?
Oh,
Yep, that was the only outstanding one.
yep.
Okay. All right. Well, with that, we'll take, I think we had scheduled a 10-minute break. We'll kind of continue back at, I think my computer's set to Mountain Time. We'll get back at 8:52.
Sounds good.
Sounds good.
Thank you.
Hi, Casey, you have a question? I'll unmute you.
All right. Are we ready? I thought I heard somebody trying to ask, or were you trying to get a question from somebody?
Yeah, it looks like Casey Nielsen has a hand raised. I unmuted you, Casey, if you want to ask your question. Maybe an accidental hand raise.
Yeah.
Okay. All right. We'll try.
I think people have seen this, so I'm not sure if they have, but Tina put in the chat about how the handouts that you can download from the handouts tab. If you go there, it takes a packet where you can then document your CEUs for today as well. Just got to reminding people of that.
All right. With that, we'll go ahead and continue with the presentation and try to pick this up a little bit. Sewer line CCTV inspections, or also known as closed circuit television inspections of a sewer, provide positive and reliable information for general sewer conditions, issues, and location of these issues, and more. Right? CCTV can be used to evaluate public and private wastewater collection systems of all sizes. This information can be used to prioritize repair work, assign more time to problem areas, ensure the proper equipment for your system is available, and help make adequate funding decisions, right? This little guy does a lot in your sewer system. So there's a lot of pros to CCTV inspections, right? CCTV allows you to see structural conditions, integrity, leaks, sags, lateral locations and conditions, roots, fog, fats, holes, and greases, right? The biggest con to CCTV inspection can be time consuming. Right? It takes a lot of time to get all your CCTV inspections done. So depending on your sewer system management plan, you need to be really strategic with your CCTV inspections. And we'll talk a little bit more about sewer system management plan tomorrow. So here's some questions that you want to ask yourself with CCTV inspections. What pipes are the highest priorities for your inspections? How often should you inspect these high priority pipes? What is the inspection frequency for the low priority pipes? Because you still want to see those, right? What equipment is required for you to do this work? What equipment can be purchased by the utility versus contracting it? Because sometimes contracting a CCTV inspection crew may be beneficial to your team. What is the personnel requirement for the equipment, right? What kind of software do you need to capture and analyze this field inspection data, right? It's not just about recording videos, but where you're going to store them for review and you're being able to make some good decisions based on the data that you receive. What coding system will be used, right? We'll talk a little bit more about that in a bit. What type of training needs to be done? How will the inspections impact your decisions, right? How's data stored, managed, and used, right? There's different standards for sewer line CCTV inspections. Sewer line CCTV inspections are very effective for quality assurance and quality control, right? They are required for in most sewer system management plans, or in all sewer system management plans. Typically they work with all utility CMMS systems, computerized maintenance management systems, right? These are like automated systems that help you prioritize your management of a sewer system. We'll talk a little bit more about those, I believe, later today or tomorrow. And like we said, they can use NASCO's PACP grading system, which NASCO is the National Association of Sanitary Sewer Contractors, and the PACP is the Pipeline Assessment Certification Program. It's a very common standard that's used in grading your sewer system based on your CCTV inspections. We'll talk a little bit about NASCO's grading system, right, and what that means. I'll kind of show you guys that. NASCO has a pretty standard way of kind of breaking down the condition of your sewer system, right? If you see a minor defect, but it's still in great structural condition, it's considered excellent. If you start seeing some deterioration, but there's no real risk of collapse, and it's still something to document, but it's still good, right? Now, it's starting to worsen, right? That'll be considered a fair grade or a level 3. If you're starting to see that a collapse is probably going to happen really quickly, that's going to be a grade 4. And if this is already broken, or it's about to break in no time, and you need to get a crew out there immediately, that's a grade 5, and it's a typical breakdown of the NASCO certification system, or very summarized version of that. So now, just to break it up, let's ask another quick question. If your camera becomes wedged during a video inspection, which of the following should be your first step in solving the problem? And I'll give everybody a few seconds and see if I don't know if anybody's answering these on the chat or not, but we'll still give everybody a few seconds to think about it.
Yeah, some people doing the questions section. We get a lot of D's so far.
What was that?
We get a lot of answers of D so far in the
Okay.
questions. If you go to
awesome. Yeah. I can't see those for some reason, so I don't know if
we'll
they're.
get a bunch of D's, so let you know.
Okay. All right. But of course, and it sounds like a lot of folks are already kind of getting to the right answer, right? I mean, before trying all these other things, definitely attempt to free your camera with the tagline. That's step number 1. All right. Let's talk real quick about other pipe inspection technologies. There's also nozzle-based camera platforms. These are kind of great. Maybe not as detailed as your typical CCTV truck, but you'll connect these things to. Once again, not advertising for anybody in particular. There's different companies that have different types of cameras, but these are nozzle-based camera platforms that just help you see everything at a quick glance using your accommodation units or jetting or sewer jetting trucks to kind of get that camera out there and record on the way back. You do have some independent crawler cameras that are not as big as your your typical CCTV trucks. Sonar, acoustic transmitters, digital scanning, electro scanning, which is kind of a neat way of inspecting, where you kind of fill up your pipe with water and just kind of send a little electro shock wave through it, and then it'll give you all the deficiencies within that pipe. Great systems out there for CCTV inspections. Just want to put them out there. Now let's get a quick math question in here. I was trying to get creative without feedback on how we can do this math, so I will give everybody about a minute to kind of work this problem out, and then we'll work it out together. So the question is, on a 12-inch CCTV on a 12-inch sewer has been completed, and the footage meter indicates that the distance is 530 feet. The plans show that the run is 500 feet, and the field measurement has confirmed this. What is the percent error in the footage meter? I'll give everybody about a minute here. I think some of you guys are great at math, so hopefully doesn't take you guys as long.
So far, we're getting a couple answers between 6%, 5%, 94%, 3%.
All right, well, that's good. I mean, so some of you guys are on. So just for a quick review, right? How you determine your percent of error is really the difference between your meter distance and your actual distance, right? And there's an equation here for it. So for those of my folks that are maybe not the best at math, or math is your area of struggle, I've kind of tried to break this down as best as possible, because really you need to just take those things and kind of plug in what's given to you, right? You plug in the 530 feet, which is what the meter says it is, right? You subtract your 500 feet, which is what you've confirmed is the actual distance, right? Then you kind of work your math from there, right? And then you kind of use these old school math principles, right? The PEDMAS, right? Please excuse my dear Aunt Sally, or some of you guys have different methods of remembering that. So you do parentheses first, of course. You do the math inside the parentheses. So you subtract the 530 minus the 500, and then you kind of do the multiplication and division kind of equally across, right? So you end up with multiplying inside the parentheses 3,000 divided by 500 feet, which for those of you guys that answered 6%, you guys were spot on. So that's how you measure that. Now, let's note that if an error is greater than 1%, you need to record it, and you need to correct it. You get a meter calibration happening on that CCTV inspection, or on that your meter there. Other quick things that I wanted to talk about was smoke testing. Smoke test is a sewer inspection method where non-toxic smoke is forced into a sewer system via different system access points. Smoke makes it all the way through the connected pipes in the sewer system, indicating pipe leaks, breaches, holes, cracks, uncapped lines, and other defects, right? Smoke testing is a very cost-effective way of determining I&I and different issues. Now, the important thing with smoke testing is that you do need to let the public know that you are doing this. People tend to freak out if they start seeing smoke coming up their street, right? So communication is key when it comes to smoke testing, because even you put out flyers, you let the local news know, it's written in the papers, and you schedule it accordingly, you will still have folks freaking out about, hey, there's smoke coming out my front yard, or there's smoke in front of my house. And now, safety, right? Only use smoke candles that are designed to for smoke testing. It has to be non-toxic smoke testing candles only. Not using the correct equipment could be hazardous to your health and property. Once again, the sound may not work on this, or will not work on this, but let's I'd like this little short video of, and I'll mute this for myself, a little short video of kind of smoke testing, what it looks like out in the field. What they're doing is just kind of blowing smoke through the lines to kind of see where your deficiencies are. So I'll kind of skip through that a little bit too, so save us a little time. Another great identification tool is dye testing. Dye testing is a method used to locate points where rain or groundwater improperly enters the sanitary sewer system. Dye testing is commonly used to confirm approved or non-approved connections to a public sewer system. All right, you can use dye testing to determine your cross connections, your unregistered or unpermitted taps. It is a great tool to determine the velocity and flow of a segment, and it can help you identify exfiltration. Dye testing is also another cost-effective method of of inspection and testing, right? And like that one, I mean, there's different colors of dye for sure, but that one's green is my favorite just because you couldn't tell already, I'm a Ninja Turtle guy, so looks like the ooze, right? Tools that you need for dye testing is dye, PPE, right? Gloves, eye protection, etc. A camera to see is really helpful to document where you see your dye, right? Typically, you need 2 people to perform a dye test, 1 upstream, 1 downstream. You want to determine your entry point, right? Whether it's going to be a stoning bowl, a toilet bowl, or a clean out, or a manhole. Now, keep in mind, traffic control may be necessary, may increase the requirement of just the 2 people if traffic control is needed. You want to ensure that you're going to have enough water in the location where your dye test is going to happen, and you want to determine where you're going to make this observation. Now, the next step would just be apply the dye, wait, observe, and document, right? And there's different types of dyes out there. There's liquid dyes and tablet forms. I will say, especially with this, if your entry point is a toilet bowl or a clean out in somebody's house, dye can get a little messy, right? I mentioned that staining is possible in the toilet bowl, and I definitely have experienced that. Some customers are not very happy. One, because a lot of times if you're trying to determine whether somebody's toilet is not properly tapped in or legally tapped into your source system, you're usually at the customer's property, right? And they're probably not happy that you're already questioning whether they're connected to your system or not. And it only makes matters worse when you leave dye all over the place, all over a toilet bowl, all over a clean out. But it is kind of one of those things, the reason why I tip my hat off to a lot of folks that are still out in the field operations teams. Dealing with these customers and trying to find answers to these questions are not always the easiest thing to do. So all things to be aware of. Also, no, do not use powdered dye in windy conditions. That's important, right? That can get all over your eyes, and that's the importance of the PPE. It's kind of hard to get that stuff in a clean out or a toilet bowl if it, especially a clean out outside. I've had that experience before if it's a little windy. So short little video of dye testing. I don't know if we really need too much sound on this one, just to see how dye testing works. You're going to see them. Oh. They're going to apply the dye, see it downstream. And I apologize for these videos not having any sound. And these videos were meant to be a little bit more entertaining, so, but. You definitely want to apply enough dye that you're going to see it downstream. And usually the colors are pretty fluorescent, pretty clear when you see them. All right, so let's do some quick dye testing math. It takes you 5 minutes and 15 seconds for dye to travel the distance of 575 feet through an 8-inch sewer. Now, what is the velocity in feet per second? Now, I will try to give everybody another minute to try to work this math problem out. And if somebody can help me out and just let me know if there's any answers that start popping out on the screen.
Started rolling a little bit. least one. I'll let you know more coming.
Okay. Yeah, some of you guys are quick.
I want to make certain that they get a chance to solve it for themselves. All right, I'll wait for one more answer to come in.
Kind of help some folks out.
Between 1.83 to 3 to 1.82 to 7. So got a couple range of answers.
Awesome.
Largely 1.82 is the or 1.8 right around the range is what we're getting.
Awesome. So I mean, I just to help a couple folks out there, I put the formula up there for velocity, right? Distance in feet over time per seconds, right? So just like the other question, you're going to want to plug and play, right? So I think some folks get a little confused with the time in seconds, right? If I'm giving you minutes, you obviously have to convert that into seconds. So times by 60 seconds. Some of this, you know, math is simple to folks, not as simple to others, right? So 1.82 or 1.83, depending on how many decimal points, 1.8 is a pretty good answer for those of you that got that really quickly. So,
yeah,
right.
Majority did.
What was that? The majority did? That's good.
Yes.
All right. So let's get into the typical operations and maintenance, right? And I really kind of did this section of pipeline cleaning because it's a lot of what we do. It's a very important part of what we do. So sewer line cleaning, right? The objective of sewer line cleaning is to minimize sewer stoppages and sewer system sanitary sewer overflows, reduce odor complaints, help reduce lift station failures. Things that you need to consider really is the frequency. Many agencies try to clean their entire system every 3 to 5 years. Initially, when I first got into this collections department 18 years ago, we thought we can clean 300 miles of pipeline in a year with 2 trucks. We found out quickly that the approach was not the most effective to give a timeline and how often you wanted to get to it, right? You really want to just be predictive, right? You want to do predictive maintenance, right? Use the available data to focus on areas of need, right? So if you know certain issues, certain neighborhoods or certain areas have big root issues, or you tend to have an industrial area with a lot of fog, those are the areas that you really want to focus on. Now, you are going to want to still clean the rest of your system, but the frequency may not have to be as often when it comes to it. Corrective and emergency efforts are always needed, but great preventative maintenance, a great preventative maintenance program sharply reduces the frequency and the costs. Now, I wanted to throw that in there because a lot of times we talk about sewer line cleaning, or I like to talk about sewer line cleaning, and obviously I ran a combination unit for a long time. But sometimes some of these other pieces of equipment, which we'll talk a little bit more about tomorrow, get ignored. What you're seeing in your bottom left screen here is called a bucket machine. It's another great way of cleaning out a sewer line, especially bigger lines with a lot of debris. So now let's talk about the types of stoppages or types of things that create stoppages out there, right? So there's roots, right? So you'll see a lot of root issues out there. One of the beauties of working in the sewer collection system is, it tends to have all the proper nutrients that roots want to grow, right? So they are drawn to it, right? The moisture content, the mineral content, right? Soft blockages are another reason for a stoppage. Usually soft blockages happen because there's not a lot of flow, or it's a low grade, and those are usually easy to break up, but they will create a backup. It's another reason for a soft blockages are rags and plastics in the sewer line. Construction debris, very common to see construction debris inside a sewer line. This often happens because very common when manhole lids are often knocked out during street repairs. Another reason for stoppages is pipe defects and joint failures, solidified grease, right? Especially those industrial areas, or some folks, right, dump a lot of grease in the sewer line. There's certain neighborhoods that'll be heavy in grease, and grit and debris buildup, right, from detergents, eggshells, and other sands, silts, rocks, and of course vandalism. I worked a sewer spill many years ago that was all because of vandalism. Some of these manhole structures, we had folks that were actually living inside of a manhole structure, believe it or not, in a kind of remote creek area. And vandalism, their kind of bedding structure inside the above ground manhole structure broke apart and plugged up a 21-inch sewer line that just happened to run down the middle of a creek. Not the funnest SSO to deal with. So another quick question. What items would you consider when selecting a solution to clear a stoppage in sewer? Your options are A, the cause of the stoppage. Option B, staffing requirements. C, chemical needs. Or D, the time of day.
While people are answering this one, we have a question in the chat. How do you mitigate those sites that have high grease?
Well, really, high grease is kind of mitigated, one, by just trying to communicate to your customers as best as you can. And sometimes that works. Public outreach makes a huge difference in just letting them know the impacts of fats, oils, and greases in the system. But more often than not, it's going to require a lot more cleaning. Now, I will say different types of pipe installations are less susceptible to grease buildup, right? You may not see it as often, PVC, as much as you will on like a cast iron or a or PVC or clay pipe. So PVC, VCP, I'm sorry, clay pipe. So that's the best advice. Now, public outreach and frequency of cleaning. If you can't clean out, if you can't replace the pipe type, but even replacing the pipe type may require a level of outreach and cleaning.
Yeah, including, I would say, make certain your restaurants have good grease interceptors, grease traps, and that they clean them regularly. That's one of the biggest things that can happen frequently too, where they don't maintain those grease traps and they just become pass-throughs effectively. So the answers we're seeing largely A, a few maybe a few B's, some all, but first A is the way to go, and then we've got A and D as well. Okay,
well, A would be the correct answer. Now, I've actually included questions that I saw in like some practice exams out there. Some of the questions are a little confusing. One of the things that I like to tell operators, especially, I used to do a lot of training, and the trainings are a little bit easier in person, of course, because you get the feedback and you have a little bit more conversational piece. But one of the things that I always like to tell operators, even the operators that I worked with as I was helping them pass exams, you got to select the best possible answer, and sometimes that gets a little confusing. I did throw in a traffic control question, and we'll get to that. I'll talk a little bit about the difficulties with testing or the way these tests are kind of built up, and we'll get to that when we get to that. So we'll continue on with this presentation.
We got another question about why A is the correct answer. How would you know what the stoppage is the question.
Well, it really depends on the area, right? So typically, you're right. A lot of times you're going to figure out the cause of the stoppage a little bit after. In this case scenario, though, it does make up the best. I mean, the question is, what items would you consider when selecting the solution to clear a stoppage, right? Now, staffing requirements, you got to clear that stoppage. So staffing requirement. Now, I don't know an agency that's going to say, hey, you can't clear out this stoppage because you don't have enough staff to do it, right? You're going to get the appropriate staff to get out there. And a lot of the stoppages that I've worked with, or a lot of the sewer system, the SSOs that I've worked on, it's usually a multi-departmental cooperation. You may have your traffic team out there. You may have your we've had park crews out there just to help out because the demand was so high, right? So staffing requirements wouldn't typically be the best answer. Chemicals were kind of beyond what chemicals are needed, right? What time of the day? Those things are kind of irrelevant to what you're trying to accomplish, which is, selecting a solution, right? So you're right. That question is, you may or may not know the cause of the stoppage until you're done, right? But in this case scenario, and really I pulled this from a practice exam somewhere, so forgive me, whoever didn't like the question, but it's just the only answer that makes sense considering you're already at worst case scenario, which is a stoppage.
Yeah, just clarify, the person was thinking that maybe D, because the fact traffic may impact your solution, I think is their thought. So
yeah, and
most of the time of day, and think about traffic, as you had mentioned, you'll talk about later.
Yeah. So, all right. Pipe cleaning methods, of course, the more common one now, it used to be rotting, but now hydrojetting is becoming a very common way of cleaning out your pipes, right? Performed using water at high velocity to clean. Of course, there's also mechanical cleanings, right? You can use hand rods. You have to be alert with hand rods. I like to throw that out there because use hand rods before, and some of you guys that have been in the industry for a while and use hand rods know that these things could kind of get bound up and smack back at you. I've seen broken jaws and broken hands because of them, right? So it doesn't look like there's a lot of tension until you realize it lets go, and it just kind of comes back to me and gives you a good waking call. Rotting machines, also very common in the industry. Less and less common, a lot of injuries. Actually, used to have a director that used a rotting machine. It was kind of interesting. He was missing a finger or two. You always see a couple of old school guys in the collections operations work that may be missing a finger or two because of rotting machines, right? We talked a little bit about bucket machines, and we'll talk a little bit more about them tomorrow. Same picture I think I used earlier. Kites and bags, pig swabs, right? All things that you use typically for force main cleaning. And of course, there's chemical cleaning methods such as foaming, dusting, or liquid chemicals that you may use. Typically, if you do use the chemical cleaning, right, you're going to need to reapply the chemicals every 2 to 3 years. Now, we'll talk a little bit more about the high velocity cleaners or hydrojetters, right? Not once again, not advertising a particular brand, but I did use a Vector brand, so it's what I'm most familiar with. Did test out a couple different brands out there. I realize when you talk to collection system operators, and we all kind of get into what our particular brand is. There's big VACCON guys, there's big GapVac guys. There's overall, we're all used to calling them. Some of us are used to calling them the Vectors, right? But these are combination units or high velocity cleaners and hydrojetters. Great effective way of cleaning, right? Very effective on grease, grit, gravel, and debris. In combination units, it's called a combination unit because you have the hydrojetter combined with the vacuum system or a vacuum unit, right? So those work great to suck out any debris that you're pulling out, right? You can use specialized nozzles for different applications, which is great. You can reach distances from above 500 to 700 feet via a high pressure hose, either a 3/4 inch or a 1 inch hose that's usually on a reel, or definitely on a reel, usually on an automated reel of some sort. I will say I used to work with a lot of old school operators, and I can probably get into a lot of stories of the guys that trained me, right? Some of these guys loved having hose reels that may reach up to 1,000 feet. The problem with having a hose reel that long is you lose a lot of the pressure and effectiveness. Also, I wanted to throw out that if you are going high distances and don't need to, usually that's going to create a higher pressure at the end that or that's going to be really susceptible to kind of creating those burp issues, right? At different homes or different locations. And I probably should throw in a slide about that, but you want to be really strategical with the distance that you're using on your hose reel. Back to hydraulic cleaning. High velocity cleaners are extremely effective with removing emergency blockages in a timely manner. The biggest cons, there's always a potential for flooding a residence. That's what we're talking about. Kind of when you have a little back pressure, those air vents are clogged up and kind of burps back up into the residence. It's challenging to clean steep grades. Well, we did have some lines that were on a 6%, 8% grade, which was incredible. And going at a distance of 500 feet with those hydro excavators, despite the fact that you have maybe 2,000 pounds of pressure going up at the end of the hose, you've dissipated so much pressure due to the friction throughout that hose that you may not get that distance out of that. This is one of those notes that I wanted to throw out. Really, operator experience matters. The more experience, the more effective and efficient you typically are, right? A lot of operators are great at what they do, and you get familiar with the system. You get familiar with your grades. You get familiar with the traffic control in that area. It makes a difference. I wanted to throw that out there, especially for those of us and those of you that have been in the management side of things, right? You want those experienced operators. They matter. A lot of these jobs can't be done without them, right? So everything I know, I learned. There's not a lot of trainings like this out there. A lot of collection systems trainings happen out in the field, right? And this all happens because of those operators with tons of experience. Speaking of the operators, this video is kind of near and dear to me because this is the crew that I worked with. So you can see our crew out there kind of doing their thing in a residential area. Now this was one of those outreach videos that our agency did, right? So very neat to see the work that's being done and how they do it. So.
Question in the chat. Is the term for loss of water pressure from the friction through the hose called head loss?
Head loss, yes. You do have. All right. So let's talk about a little bit about nozzle selection. Nozzles have various jets and angles, right? So we talked about those experienced operators and what they do. An experienced operator is going to know what nozzle to select at what time, depending on what you're cleaning, right? They're designed for different pressures, flows, and pipe sizes. We talked a little bit about it earlier, but some nozzles will require skids to keep the nozzle centered in the pipe for effective cleaning, especially when you get into these bigger, above 8-inch pipe sizes. It really matters to have that nozzle centered in the middle of that pipe, because you get into a 12-inch line or 18-inch line and that nozzle is just kind of getting the bottom. You're not really getting any of that buildup around the pipe. Really matters when you start dealing with fog issues, right? So these skids here are important. I used to have a boss that was really big on us using the appropriate skid because it kind of also worked as a way to kind of just confirm your pipe size, right? So use a 7-inch skid for an 8-inch pipe, really help see if there was any offsets on that pipe, right? Your nozzle helps propel the hose upstream, right? Those of you that aren't familiar, your sewer cleaning actually happens when the hose is being pulled back downstream, right? You want to get your nozzle and your hose upstream as quick as possible, and then kind of be slow and low, drop your pressure, and just getting the effective cleaning on the way back downstream. Effective cleaning will break up and pull back any material. Heavy debris should be removed via vacuum units, clamshells, sewer baskets, to avoid additional maintenance at downstream lift stations or treatment plants. I wanted to throw that out there because based on operator experience or complacency, sometimes we just keep sending this grit and debris downstream. Well, it doesn't just go away, right? It ends up at a lift station or somewhere else, and it's going to have to get cleaned out anyway. So I always recommend, hey, if you can vacuum it up, or if you can use a clamshell or a sewer basket to remove that stuff, then remove it then. A little bit more on nozzle selection. There's different types of nozzles out there. so many cool, and when you start getting into the nozzle technology, sewer operators that run these combination units or jetting units geek out a bit, right? There's fixed cleaning nozzles, right, used to clean an entire circumference, right? Usually their jets are 20 to 45 degrees. These are great for stoppages, used to break up stoppages. There's some great nozzles for stoppages, I'm sorry, that are used to break up blockages, right? Some forward facing nozzles help kind of break up whatever's upstream, whether it be grease, sometimes roots. We do have some flushing nozzles that are used to move debris from the bottom of the pipes. Usually those the nozzle degrees are a little different there. You have some large skid or culvert nozzle types. Those are usually used for cleaning up the bottom of a pipe. I think I have a picture of that here. Yeah. Bigger pipelines, heavy debris. Most common nozzles are 15, 35, or 45 degree discharge angles. A little bit more on specialty nozzles. You have some rotational cutting or chain flail nozzles, right? Rotational nozzles use revolving jet heads, kind of like this famous nozzle in the industry, to break up roots, stick, grease, or scale. Yeah, some cutting nozzles, right? You have a rotational element with the addition of a cutting head to assist you in cutting out thick roots. I will tell you, caution, these do get stuck. That's one of those experience things. Chain flail nozzles, another rotational nozzle with the addition of chains intended for cutting, right? Helps break hard scale buildup. Or very, very effective tool. Another thing though, based on experience though, you want to be careful with a chain flail. Those chains have to be set up for the right pipe diameter, because you may damage the pipe. We've broken up some good new PVC with some hard scale buildup. We've broken up some clay pipe definitely with some chain flails. So keep in mind, right, the risks with your nozzle selection. We talked about the methods for debris removal, so I wanted to go back and show you guys what a sewer basket or a clamshell may look like. These are all things when you're cleaning a pipe with a sewer hydrojetter, right? Things that you may want to have in your truck just to remove that debris. And of course, a vacuum tube. Now, I'm going to touch on this real quickly, but this is one of those kind of like the traffic control where I've realized that based on who you're talking to and what study you deal with, your explanations of nozzles and nozzle tiers can get different, right? So there's certain nozzle salesmen that'll tell you there's only 3 tiers. There's certain, obviously, like this one where I pulled it from Aquatech, that tells you there's 4 tiers of nozzles, and tiered nozzles are always different based on the direction of flow and how efficient they are. One good thing about it though is I haven't seen a test question yet that includes nozzle tiers. So this is more of an information, not really a you need to know in the industry, but like I said, depending on who, not really a test thing, but something you need to know, because depending on who you talk to, you're going to have different tiered definitions. Typically your tier 1 nozzles are your just, hey, there's some openings at the end and it kind of cleans out, right? And it kind of shoots out the water at X amount of angle. The higher the tier, usually you're going to have the rotational aspects, or more channeled in concentrated nozzles that'll make the efficiency of cleaning a little bit better. So a couple of safety items that I want you guys to be aware of. Nozzles can propel themselves out of the lines and cause injury to operators. I used to see this safety sign in combination units all the time and never thought it was all that serious until I actually saw it happen once. I think in 10 years it happened once, but you have to be aware of it, right? Bends, offsets, and breaks in lines may prevent a hose from being reeled back in. Keep that in mind. What do you do when that happens, right? You want to slow down, shut down the hose, or slow down the hose or shut down the hose for a period of time. And then keep in mind safety safety-wise, a stretch hose may break, right? So a lot of times we just want to get that hose unstuck when we're trying to reel it back in. We have had that scenario where folks hoses get stuck and it gets stretched and ends up breaking and potentially hitting an operator. Unfortunately, we've never had an injury, but I have seen the hoses kind of stretched out, break. Set up and follow all appropriate traffic control regulations for the traffic in your work zone. We're going to talk a little bit more about traffic control if you guys attend the training tomorrow. But I did want to mention it a bit today for those of you that are not in tomorrow's session. So more staff may be needed in heavy traffic areas with major blind spots. Use the appropriate PPE to prevent debris or hazardous fumes or mist to contact your face or in body, right? You don't want to be this guy on the bottom left. It's crazy, some of the things that you see out there.
Quick question.
Yep.
Person new to the industry, how do people prevent the likelihood of these injuries?
Well, mainly awareness is the biggest thing with preventing injuries, right? Making sure that you're aware of where that nozzle is at all times is really important. Definitely understanding your traffic control safety regulations and where you're at in that traffic area. Maybe not being too complacent when a hose is stuck. If a hose is stuck, you got to try multiple different things, and obviously you have to try to get that hose unstuck. But communicating, usually folks don't want to say, hey, I got this very expensive piece of equipment stuck in a sewer line, I need some help, right? But usually that's the best case scenario. Slow down, ask for help, communicate, get the proper teams out there to help you. If you feel like there's not one, I've learned, especially with a stuck hose, I've learned to just be patient. Like I said, I wrote in there to slow down and shut down your combination unit or your hydrojetter for a while. Let the kind of pressure dissipate a bit. I've had a lot of success just kind of grabbing and maybe pulling that hose with a little less force than what you think the hose reel is doing. Hopefully that helps answer your question, but most of your safety incidents happen because of complacency and lack of awareness, right? So just be aware. Okay, so the question was, emergency stoppages in pipelines may be cleaned out safely by the use of A, high velocity cleaners, B, balling, C, kites, or D, bucket machines. I'll give everybody about 30 seconds if you guys can help me when answers start coming in.
So yeah, they're starting to roll in. Looks like we're getting a consensus around A right now.
Great. And that would be the correct answer. Now, all those other things are great for cleaning, but it's not typically what you're going to want to set up for a stoppage. Right? Very effective. Now, I threw this in here, even though we're discussing traffic control tomorrow, because I was curious on what most folks are going to answer here. Question is, there are blank different areas of traffic zones when working in roadways, and the answers are A, 4, B, 7, C, 5, or D, 6.
Answers are slowly rolling in. So we got a mixture of answers a little bit. We got answers of A's, C, D. Yeah, pretty much. I see all answers except for B, although tough to say because a couple people answered differently. It's kind of A's and C's, kind of the big prevailing with a couple D's.
All right. Well, that's great. So A's and C's is what I typically expected. Now, I am going to tell you C for 5. Here's the key on this, and I wanted to really, this is more my operator event. I'm just going to get comfortable and vent to you guys a little bit.
Yeah.
I've looked up, I've gone to multiple traffic trainings. I've went through the Ken Curry books and went through all the different, I've gone through quite a bit of traffic control training within sewer department or the sewer collections department within the water distribution department, kind of in the construction industrial area now. And I'll be honest with you, there's not a good general consensus. And I'll tell you guys now, the Ken Curry collections book actually has 4 as the correct answer, right? And what I've noticed is why I highlighted and read this traffic control area, because I think it's an important area that often gets ignored, right? The common areas that you see in traffic control is advanced warning, transition area, work area, and termination area. And I think the biggest debate, whether they know it or not, and I'm really to the point where I want to send some type of email and to try to get the industry to just kind of, hey, let's all at least get together and get the right answer. Because I've been frustrated. I've taken all these exams along with you guys, right? And you know, I'm one of those geeks that wants to aim for an A, or you know, if I got a 91 in my first distribution exam, and I was so frustrated with it because I thought I nailed every question, right? And then I realized, well, because it really depends on who's asking the question and who thinks the right answer is right. I'm telling you guys, the Ken Curry, the famous Ken Curry books that most people reference for a lot of these operator exams actually tell you that there's 4 traffic zones in a roadway. Yeah, they ignore the buffer area, right? Now, I will tell you that 9 out of 10 traffic control trainings that I have attended included this buffer zone, right? Which is, for me, a very important zone. Just kind of gives you that extra buffer before your transition, where you're making traffic transition in your work area, right? You need to have that extra gap if possible, right? It's not always possible to get that good buffer, but hopefully that's not in a high-speed area. So there's my little rant and on that, because a lot of the information for these operations exams are difficult to get to, and to top it off, sometimes the information is not consistent. And I'll tell you that Ken Curry book that I got was the most recent. I literally rebought the books for this training, and it still has 4 different traffic control zones. So just throwing that out there. All right, next section is going to be a quick one. It's going to be, I know I'm running out of time here, so it's going to be on record keeping. Records are an important part of lift station pipeline cleaning, and are important for lift stations pipeline cleaning, goods received. Sorry, been talking for too long. And sewer inspection operations. Records help us in prioritizing future projects and maintenance activities. Pipeline records should include lines cleaned with IDs, cleaning methods, and the length covered. Lift station records should include electrical power costs, fuel costs, operation and maintenance costs, scheduled preventative maintenance costs, unscheduled repairs and costs, vandalism records and costs, right? All those things are really important to keep records. There is different ways of kind of tracking your cleaning or keeping records of your cleaning, and I wanted to throw it out there. There's a lot of programs out there that'll help you do this, right? So what I did was I kind of highlighted there's some agencies that are really fortunate to have these integrated programs with your CCTV inspections and your sewer line cleaning inspections, your manhole inspections, and have it all documented all in this great system that's maybe all integrated with global positioning software. That is great. Not every agency has that, and I was fortunate enough to work for the agency that I worked for during our transitional period, right, where every piece of documentation happened just kind of like this one on the right, right? We're all the old school champions, where the only way that we were documenting what lines were being cleaned and what was done was a highlighter, right? And if you did it multiple times a year, it was a different color highlighter, right, on a big map. Not everybody's blessed to have this cool software that lets you help keep track of all the stuff that you're cleaning, but it's important, right? You want to be able to keep those records and have those discussions to be able to see what's been done. And the new software is great because a lot of folks are out there, and you can see what other operators are doing throughout the city or throughout the agency, almost live timing if you're connected to a live database, right? But even those of you that work for these smaller agencies that aren't quite there yet, right? make sure that you're keeping records of what's being done to communicate with the agency or communicate with other operators what you've accomplished and what we need to work on. So, and I believe this is my last section for today, which is kind of your lift station overview. Lift station operation and maintenance. Lift stations, I kind of reuse that picture, right? Here's some factors that affect the lift station locations, right? Cost of excavation, right? The soil stability, groundwater table height, other short-term solutions when wastewater flows do not justify the extensions of trunk sewers, right? Lift stations are located in different parts throughout an agency for many different reasons. Out here in Texas, I've been noticing that because there's so many gaps in between different communities, community may have just one dedicated lift station bringing out to one line just miles apart from them, right? So it really depends on what zone and region you're in and how lift stations are, where the installation is determined. Now, this was a kind of another cool little video of breaking down how a lift station works. And like I said, without the sound, kind of read along. And of course, it's breaking down kind of the start of how you get to a lift station and what it does. It's very, very similar to the diagram that we saw earlier. Of course, this pipe is a little higher influent.
So there's a question someone has. It says, if a certain area repeatedly shows problems, requires more relative to cleaning, what strategies do you use to communicate with that area to reduce the problem, like excess of a specific waste?
Okay, if we could repeat that question one more time, then I'll
if a certain area repeatedly shows problems, meaning requires more relatively higher cleaning levels, what strategies do you use to communicate with that area to reduce the problem, like excessive amounts of waste, specific waste there? So I guess it's talking to the customers about, they're becoming more of a problem. How do you communicate with them? What is your strategy, I guess, with that?
We've used different mailers. If it was an industrial customer, we take, I think, a little bit more of a aggressive approach and just have a direct, conversation with them. And unfortunately, that doesn't always make a customer super happy, but it is something that we've done in the past. But usually, more of your private residencies will typically do more of, mailers are just kind of included with their bill. You can do different advertising. That video that I showed you guys earlier from the agency I used to work with was kind of part of that attempt. Hey, this is what we do and this is why we do it, right? So, nowadays, social media outreach is a very big thing. If folks are paying attention to it, sometimes it's really difficult, to be honest. Like I said, if it's not an industrial user, it's definitely a little bit more sensitive for a private residency. What do you need to tell them? But if it is an industrial user, I mean, a direct approach works because they're making a significant impact to your system. And usually those industrial users have a little bit more stringent permits, right, for your collection system and what they're required to abide by. So you have a little bit more backing on, hey, this is what when you applied for this industrial waste permit, This is what the rules were, the bylaws that you agreed to, and these are not being upkept, right? So I guess that's the best advice. Some of those things, like I said, I always sympathize with our field teams, and I was part of the field team for 8 years. I realized that there's some uncomfortable situations out there, especially when you have to be a little bit more confrontational about, hey, this is what you're doing. Usually when you have those conversations, I would recommend usually go with a team. Hopefully your management staff is involved enough to have that conversation as well. And I mean, you may need the customer service team to make phone calls as well, or that's the best way I can answer that question.
Okay. A follow-up question was, for problem areas that get cleaned more often, let's increase the likelihood of damage to the pipes.
Depends on what type of cleaning you're doing, right? If you're doing like a root treatment, or your typical hydro cleaning with the right nozzle won't really damage pipes so much, unless you have cracks and breaks, right? Now, if you have a break or a crack, you kind of need to grade that a little higher and get that on a replacement schedule sooner, right? So that's the reason for, there's the coordination here with the inspection and testing and the the cleaning methods here. Those both things are incredibly important. So if you determine that this has a break, you need to put this on a replacement plan. Now, cleaning itself shouldn't damage your pipe unless, like I said, you're dealing with a chain flow. The cleaning itself usually kind of gets that surrounding area of a pipe, like we talked about earlier. That you're getting a great effective cleaning with those sewer jetters or hydro cleaning methods, but you're not usually don't have so much pressure at the end of that nozzle. It's enough pressure to hurt you, but it's not so much pressure that it's going to really damage the inside of that pipe, unless that pipe is already in pretty bad condition. So it's not going to make a major impact there. I have seen nozzles that kind of shake a little bit more, or try to kind of beat the bottom of that pipeline a little bit more. Now those can be a little bit. A lot of sales folks will try to sell you on those. Those could be a little bit tricky. So
I'll be mindful of time, but the person made a follow-up comment about there's a certain level of local politics that play into these discussions as well too. I think it's just important, but I also don't want to hold back your conversation.
No, it's okay. The questions are good. So now we talked about the video kind of showed different types of lift stations, right? There's submersible lift stations. These consist of a wet well, valve pit, control cabinet, right? We've seen pictures of these already. I did want to talk about the different types of lift stations. Suction lift stations, which are usually mounted on the top of a wet well instead of inside. Draws the wastewater vertically. Typically, these type of lift stations don't have valve pits. Dry pit lift stations, right? We'd call these wet well and dry well, right? So your dry pit is our buildings with a below grade wet well and dry well, or dry pit or dry well that is separated by a concrete wall. The wet well collects and stores the incoming wastewater flow. The suction pipes penetrate the wall into the dry pit side, and that's where all your pumps are and discharge piping is. These are great, right, for maintenance purposes. It's easier to maintain these. Usually you'll see a wet well dry pit lift station when you get into the bigger, higher flow lift stations. And that's kind of more of how this is more of a submersible look, right? But now the requirements of a lift station, they're designed to remain fully operational during a 100-year storm. So when you're designing lift stations, you want to keep in mind your worst case scenarios. The stations should always be accessible to crews and vehicles. Aeration is another, or aeration of the process of adding air to water may be needed for long-term detention wet wells, right? That's an important part here. We get a little less time for this math question here because we're running out on time. So quick math, the pumps in a 6.5 foot diameter wet well operate between a high level of 6 feet and a low level of 2 feet. What is the volume of the operating level? And I'll go ahead and give you guys the formula for that. Kind of give this.
Answers are still, we got one answer in so far, waiting for more to come in.
Wow, some of you guys are really impressive with your math answers. That's great.
Yeah.
And we'll kind of start plugging and playing some of these numbers, right?
Still just one answer in. We got a couple answers in now. No, revised answer is what it is, actually.
These are kind of your typical.
Yep, there you go.
Sorry.
Yeah, so eventually people start settling on that number too, 992.
All right, awesome. These are typical math questions that you'll see on an exam, so kind of threw them on there. Another math question: the storage volume in a wet well between high and sorry, typo there. I just realized low pumps for pump starting and stopping is 1,000 gallons. The actual pump capacity, the pumping capacity is 50 gallons per minute, and the flow in the wet well is 25 gallons a minute. What is the pump operating cycle time? So the storage volume in a wet well between high and low levels is what that was supposed to be. I apologize for the typo, everyone. For the pump starting and stopping is 1,000 gallons. So I'll give you guys the formula here to get through this a little faster. And I don't know if we're getting some answers here.
Not yet. It is into the session though. So we got one answer, 40 minutes. 40 minutes, 1690. 40 minutes. Yeah, it seems to be settling on 40 at this point.
All right. Sorry, I'm trying to get back into my presentation here and then.
I understand.
Yeah. Yep. 40 minutes. So another quick math. Pumps. Oh, did I go backwards? So we'll give everybody the formula here. The pumps in a 6.5 diameter wet well operated between a high level of 6 feet and a low level of 2 feet. The actual pumping capacity of the pumps in this wet well is 50 gallons per minute. Into the wet well, the flow into the wet well is 20 gallons a minute. What is the pump operating cycle time? And what I was trying to do is just kind of demonstrate how different levels of math and different collections exams is really just the same questions. And I did this intentionally, using the same question, but just kind of combined, right? So the first thing you're going to do is calculate your volume like you guys did earlier. And now you're going to calculate your cycle time, right? Like you guys did earlier. Same question, but now you're going to you use both pieces of information to find your new answer, right? Which is 40 minutes, your cycle time. Similar. Just I wanted to show you that these questions just kind of stack up on each other. The math doesn't change that much. It's just a matter of how much of the math, right? You just basically use the same principles of both math questions in one question. So I'll get into control systems real quick. Lift stations use automated control systems to provide reliable continuous operation. Right, larger lift stations have PLCs to automate. Right, using an interface that's called SCADA, the supervisor control and data acquisition. Typically, they include human-machine interfaces. Right, that kind of display what's going on at the lift station. Alarm features should be present to alert operators when a failure occurs, right? This is why you don't need operators at lift stations 24/7. Routine inspections are very important at lift stations. Factors to consider, historical performance, number of lift stations in the area, automation controls, lift station redundancy, maintenance schedule. Every lift station should have a physical or electronic sign-in or login to track when operators visit the facility. Things to include on that should be the site, the date, the times of arrival, the times of departure, and a short summary of the actions performed. There is no frequency that's already predetermined on how often you are supposed to inspect a lift station. This all kind of has to do with your particular agency. or best operating approach that you guys determine, right? So maintenance and troubleshooting issues, right? A lot of maintenance and troubleshooting, and we'll talk a little bit more about this stuff for section 2 as well tomorrow. You get a lot of help with maintenance and troubleshooting if you have a CMMS system, a computerized management software that just helps you generate work orders, helps you plan and organize your maintenance activities. These CMMS systems will assign the maintenance to different operators, different alarm conditions, and other indicators. These programs can help you track spare parts, historical records, and provide O&M manuals. You can integrate these programs with your SCADA systems, and some utilities maintain their maintenance and activities by keeping a schedule on the maintenance sheet records. Not everybody has these CMMS systems, but they are something that I wanted you guys to be aware of. Other maintenance and troubleshooting activities, right? Panel cleaning, maintenance activities at a lift station, right? Panel cleaning, pump maintenance, greasing, checking rotations, deragging, lift station, wet well cleaning, very important part of what we do. Removing the debris at the bottom of the wet well, removing what we call at our agency the floaties, or the heavy grease that builds up on the top of a wet well. All important parts of the maintenance. I know I'm a little over, so we're just about done, guys. So I'll finish this off if anybody's still there. Maintenance and troubleshooting activities. Motor checks. You want to check your volts, amps, fuses, relays, starters. You want to test out your alarms frequently, right? You want to see if, simulate pump failures, high and low levels, intrusion alarms, general alarms, telemetry fails. Those are all things that you want to do at a lift station. Check your bar screens, whether they're mechanical, different types of scrapers, right? Those are all things that you want to check at a lift station. Now, quick safety items, confined spaces. What wells are defined as confined spaces? All confined space protocols need to be followed and observed. The confined space is, if you don't know a definition of a confined space, large enough that an employee can enter, has limited or restricted means of access, is not designed for continuous employee occupancy. Now, we're going to talk a little bit more about confined spaces tomorrow if you guys are in it, in tomorrow's training. If entering a wet well, oh, this kind of is covered up here, but gases need to be monitored via gas detector at all times, right? So if entering a wet well, gases need to be monitored with a gas detector at all times. These are some of the things that you need to keep in mind, right? Your oxygen level should be somewhere between 19.5 and 23.5%. You shouldn't have any hydrogen sulfide. Only acceptable below 10 parts per million. Now, it was our practice that if you saw anything in there, we're getting the blowers out and we're going to try to eliminate that. You want your typical gas detectors are also reading your lower explosive limit, which you need to keep below 10%, and carbon monoxide, which you need to keep below 25 parts per million. Use fall protection and retrieval systems there. I think we have a couple more questions and we're just about done. So
yeah, so we've got a couple questions. One was requesting that we recover this stuff tomorrow because you went a little bit fast on this. Don't know if you can. And then another one, what is CMMS? What is that?
Computer management maintenance software. So we will talk a little bit more about those type of systems tomorrow when we start talking about the management of a collection system. So
gotcha. Oh yeah, tomorrow is a holiday, so just an FYI, although we've already got this thing scheduled.
Yeah.
So we're gonna answers. Just change this answers between C and B and A. So we got a couple of them. Largely looks like C is the primary one, but kind of a little bit over the place.
Yep. C. Typically the human machine interface, right? I wanted to give you guys those definitions. MCC is a motor control center. RTU is a remote terminal unit. You're really going to just use the HMI to interact with the control system. And just a quick review on oxygen levels. Oxygen level alarm usually goes off below 19.5%. Like 19.5% is kind of considered a oxygen deficient atmosphere. Your normal oxygen levels are typically 20.9%. So
People do that really well. Bunch of people got it.
all right. So with that, I mean, we're done with today's training session. I know tomorrow we'll do a little bit more. Didn't realize, yes, it is a holiday tomorrow. So I know we can share this again. If you guys want to give us any feedback.
Yeah,
Yes,
please fill out the survey. We always appreciate your feedback. It helps us plan better trainings for you. And I hope we see you all tomorrow. And also remember, please download that agenda PDH form so that you can upload that to your portal accounts and get PDHs for this. Anything else, Jason or Daniel, or should we wrap it up?
I have nothing
I
else.
think we're good. Yeah, I think we're good. Thank you, guys.
Thank you.
Okay, hope to see everyone tomorrow.